So one of the concepts that I was asked to talk about in the math videos was SI unit conversions. A number of students had some difficulties with these, trying to convert between different SI units when we had different prefixes. So with these, we want to remember that there are stations, and those are set up for the International System of Units, and they were set up to kind of standardize everything because we had different units and that were not easily converted between each other. So our base units include second, meters, kilograms, Kelvin, moles, amperes, candelas. So with each of these, we can put a prefix in front of them, and this allows us to have very wide ranges of measurements, from really, really large things to really, really small things, and not having to write everything out as like a meter and then write it out with a big one where you have all these zeros, or really small things where you have all these zeros, because we end up needing all these different sizes of measurements for various things, particularly in the scientific community. But the ones that you guys memorized in order was this King Henry Died by Drinking Chocolate Milk mnemonic that allows you to have these guys memorized in order. So these over here on the left end with the kilo are really big, and the milli is very small. And it's really important that you recognize that regardless of whether we put these prefixes in front of grams or liters or meters or seconds, that a kilo in front of them is a large amount, and a milli in front of them is a small amount. So some of you had learned this King Henry slider method, where you look at sliding the decimal point over, and I know a number of you did this in biology or maybe did this in middle school. And this is a great procedure to use when you only have to take into account it's changing something where you only have units in the numerator, like kilometers to meters or milligrams to kilograms. If you have anything else, this method doesn't work. So there are a lot of limitations to this. So it doesn't work when the unit you need to convert is in the denominator. So grams per mil to grams per liter, which are things that we would use in density measurements. Or when you've got something that's in the numerator and the denominator. So like kilograms per liter to milligrams per milliliter. Or it also doesn't work when you have units that need to be squared or cubed in either the numerator or the denominator, like grams per centimeter squared to milligrams per millimeter squared. So the slider method is kind of like the basic first step of being able to do any of these conversions. But once we get beyond something very, very simple, it is not going to work. So we worked in this class of trying to use the method where we're using these with conversion factors. So if we start from this idea that kilos are big and millis are small, so for every 1 kilogram or kilometer, there are a lot of milligrams or millimeters in there. So we've got to remember that all of these things that are really big versus all of these things that are really small. So let's work through an example and see how this works out. So if we want to convert between deci and milli, the way we want to do it is we want to recognize that deci is our big one and milli is our small one. So there are going to be lots of milligrams in 1 decigram. So by recognizing this, we need to figure out how many milligrams there are in 1 decigram. So we know that we're going to have 1 decigram. equal to some number of milligrams. And the way to figure it out, and the easiest way, is to figure out how many times would we have to move over to go from the M to the D. So the M to the C is 1. The C to the D is 1. So that would be 2 times, which is 10 times 10, or 10 squared, which is 100. So that means that there are 100 milligrams in 1 decigram. So if we want to convert between decigrams and milligrams, this is the conversion factor that we would use. So let me clean this off and I'll do another one. So if this time I want to convert between hecto and deci, let's say I want to convert between hectometers to decimeters. I recognize there's 1 hectometer in a lot of decimeters, but I don't know how many there might be. So again, I'm going to count between them. So I've got 1, 2, 3. So that leads to 10 to the third, which is 10 times 10 times 10, which is 1,000. So I've got 1 hectometer equals 1,000 decimeters. So when I want to use this in a conversion factor problem, this is the conversion factor that I'm going to use. Let's try one more. So let's say I want to go from kilograms to milligrams. So I know that there's 1 kilogram in some number of milligrams, and I know there's going to be a lot here. So I'm going to look at how many times I have to count over and use that as the number of tens. I'm going to multiply by each other. So 1, 2, 3, 4, 5, 6. So this is 10 to the 6th, which is 1 million. So it'll be 10 to the 6th, or 1, 1, 2, 3, 1, 2, 3 milligrams. So these are the same. This is the conversion factor that you would use for converting between kilograms and milligrams. So let's do this example, 1.42 grams per centimeter squared to milligrams per millimeter squared. So I'm going to go back to my little drawing here. So I've got to take grams and milligrams. So put out my list of prefixes, and I've got to go from the base to milli. So that's 1, 2, 3. So that's 10 to the third. So my base is 1 gram, and that's going to equal 10 to the third milligrams, which equals 1 gram, which is 1,000 milligrams. So that's one conversion factor that I'm going to need to use. Thank you. okay? How'd it go?
Good. That was in the mail. I don't know if it makes any sense. That's true. And also, there's a Pet Supplies Plus coupon. So. What? Your buttheads.
Of course we are.
What?
Well, I'm glad you guys found the thing.
Me too. Hi, Carmel.
Dad, I've been a barking goober butt.
I didn't come close to nicking your cone the entire time.
Good for you.
Show puppy. I forgot the other thing we need to do.
What was that?
Poop bags. Oh, we got plenty of grocery bags, I guess.
Okay, I'm not sure. Commonwealth Financial Network. I don't know where this comes from.
That would be Blue Pulse.
Okay.
Right here.
The humming dishwasher? The humming?
Yeah.
Did you bring in the paint swatches?
No.
So let me show you what I have on Google Earth, and you can tell me where the cones are.
Yeah, they're not showing up on Google Earth. They weren't out when they took the picture.
I was right. It's a church near Lavera on a 2-lane windy road.
Because I'm looking at this going, you can't see Lavera from there, and I see no cones.
Yeah, you pull in there. The cones are this entire area, so that, and then you can loop around, pull in, and do it.
The cones are that entire area?
Well,
But it's only 2 parking spaces, right?
yeah, those are the cones.
Oh, those are the cones? Okay, well then I guess there are cones.
You see those?
You can kind of see them. Yeah.
But hey, we found it. And hey, I was right. Near Lavera, 2 street, windy road, church.
You're right, but you know how much I have to... You
Yeah.
can see the
You
cones.
can see the cones.
You can see the cones.
You can.
Yeah, you can, but look at how much you have to zoom in order to see them.
1, 2, 3, 4, 5.
Oh, yeah.
Yeah, they were not obvious. But then I did look at there.
I
but
was right. I
Here
was
is
right.
Lavera, and there's
we
the
saw
church.
Driving here.
Well,
It's
and
close, but
well, you would have been driving on Eddy.
Now we're going on 6.
Then how could you see across the pizza place to there?
because the pizza place is under and we were over.
Because this is 6, and then there's all this,
This is
and this
6.
is Eddy. Yeah.
There's
There's
some
the church
gaps
here.
there you can see
Oh, okay.
through.
Got it. All right. Sorry. I tried. I did look at that church, and I did miss them.
But I did really, really well.
Good.
So, Mom, paint swatches.
All right.
Just to show you. We picked up a bunch of neutrals.
Okay.
And then we found they had an entire book of whites and neutrals.
Oh, nice.
So we have that. And also,
What was that beeping?
Turn on the oven to heat lasagna.
Oh.
and there are a bunch of like whites and neutrals there and some grays. And then for potentially your room, I picked stuff out with nice, really, really super light shades.
Nice.
So those are for you.
Okay.
I picked some with a little bit more green and then one that was very blue. So with the nice light shades.
Nice.
So lots of paint swatches.
All right. Lots of neutrals.
Yep.
Awesome. So I've probably got less than 10 minutes of videoing. Is it okay if I try to finish that so I don't have to try to merge 2 videos? I'm really close. Okay. So I'm going to start. Becca?
It's such a weird freaking shape.
Last night, I had said I was going to start videoing, and then she had that exclamation, and it got picked up on the video, of which I had to go and delete and then link. Okay. So I wrote down the conversion factor here that we just figured out. 1 gram equals 1,000 milligrams. So let's figure out the next one. So rewrite our prefixes. So we need to go from centimeters and meters. So there's 1 centimeter and it equals some number of millimeters. And by looking at this, this is 10 to the factor of 1. So that would be 10. So I can go ahead and include that now on my conversion factors. So 1 centimeter equals 10 millimeters. So now I can go ahead and start setting this up in order to do the conversion. So I've got 1.42 grams per centimeter squared. And I know that there were 1,000 milligrams in a gram, so my gram has to be down here in the bottom in order for it to cancel. So there's 1,000 milligrams. And then I know that there are 1 centimeter, and that's 10 millimeters. And that's wrong. So 1.42 grams per centimeter squared, 1 gram, 1,000 milligrams, 1 centimeter, 10 millimeters. That only cancels with 1 of my centimeters that are in the centimeter squared. I need 1 more, so I need another centimeter, 10 millimeters. So that cancels with the second one because this centimeter squared is the same as a centimeter times a centimeter. So that's what I end up needing in the numerator to have that cancel. So once I've done that, I've got 1.42 times 1,000 divided by 10 divided by 10. And this is what I get. So I get 14.2 milligrams per millimeter squared. So that's because I've got a unit of milligrams here, millimeter times a millimeter, which is a millimeter squared. So let me look at another problem. So for this other problem, I need to convert from kilograms per liter to kilograms per milliliter. So I need the conversion factor between liters and milliliters. So let's do the exact same process. So it was the base of liters to milliliters. So it was liters to milliliters. So we know the large one is 1 liter. It equals some number of milliliters. Looking factors of 10, 1, 2, 3. That's 10 to the power of 3, which is 1,000. So that's the conversion factor we're going to want to use when we do this conversion. So it's 1 liter equals 1,000 milliliters. And now we can go ahead and solve the problem. So we've got 22.4 kilograms per liter. And there's 1,000 milliliters in a liter. Those liters cancel. And we get 0.0224 kilograms per mil are our units. All right. So hopefully those helped you. So practice suggestions. Okay, very similar to what I suggested with the unit conversions. This really only gets easier with practice. And you can look at all the answers from the problems we did in class, but it doesn't get easier until you actually do them yourself. We had lots of practice worksheets, and those answers are posted online. But I think that this worksheet here that was labeled Dimensional Analysis Worksheet number 2 is probably the best one for practicing ones with different SI unit conversions, because they have some in the numerator, some in the denominator. There are some that are squared. There were some that were cubed. And I think this is the best practice sheet for doing these types of problems. So I'm hoping that this helps you guys out. And if you have any other questions, send me an email. Thanks.